In this module, we will describe some of the basic concepts of SAR images related to surface water and flood monitoring. First up, why do we use SAR data? Well, radar data has various advantages in comparison to optical satellite data. This data is weather independent. This is particularly useful when there is a cloud cover blocking the optical sensors from taking useful pictures of ground. In such cases, radar signals can penetrate the clouds and capture images of the ground for us. It has 24/7 imaging capabilities. Also, it provides advanced change detection due to stable imaging geometry and its own source of signals. An example of flood inundation mapping using Sentinel-1 images. There are various radar satellite images available depending upon the frequency of radar signal used to capture them. As you can see here, each frequency with its corresponding wavelength is used for specific application. Smaller wavelengths have lower penetration ability of the signal compared to longer wavelengths which have higher penetration ability through the clouds. In this course, we will use C-band images from Sentinel-1 SAR data, which is effective for global monitoring and change detection. Let's first look at some of its properties. L-band data is ideal for the flood inundation mapping because signals penetrate through the canopy and can sense if there is standing water underneath. Inundated areas appear white in the image along with the black pixels of water. The wavelength of C-band for Sentinel-1 measures around 5.5 centimeters. It has a dual polarization that functions mainly in two instrument mode. One is interferometric wide angle, which provides spatial resolution of 10 meters. The second is extra wide swath mode, which provides spatial resolution of 40 meters. Now, let's explore how radar interacts with objects and surfaces. Radar mainly measures backscatter of signals from ground objects. There are three scattering methods. First is the scattering on rough surfaces, like water, bare soil, and roads. It is strongly dependent on surface roughness and sensor wavelength. Like, for example, if water is very calm, then there will be low scattering. However, if it is moving, you will get more scattering, as its surface will become rougher and uneven. Next is the double bounce scattering. It is kind of scattering when signals bounce off twice, once on the surface and then on another object, usually 90 degrees to the surface, like tree trunk or buildings. It has very little dependence on the wavelength. The third type is volume scattering. It mostly happens off of vegetation or dry soils with high penetration ability of the signal. It is strongly dependent on the signal wavelength and dielectric properties of the medium. The surface properties of water affect the backscattering of signals. It is important to note that during SAR image analysis, water surfaces like water bodies, flooded areas, and wetlands are recognized by their characteristic signatures. It simply means that mapping water surfaces is based upon their unique backscatter regimes, distinguishable from the surrounding land surface. For example, calm water surfaces appear smoother and cause spectacular reflection, leading to low backscatter, while the surrounding land surface, which might have some vegetation, appears much rougher, causing high backscatter. By now, you might be wondering, how are SAR images used to map water surfaces? Well, there are various methods for flood water mapping and surface water mapping. One of the very widely used methods is called thresholding. As we know, when the water surface is calm, it has very low backscattering value. It gives us a threshold to know if the value classifies as water or any other object in the image. So, below a particular threshold, the surface will be classified as water, and above that value, it might be characteristic of dry land. The second method is active contours segmentation. It is mainly used for surface water or water body mapping. It implements an algorithm to delineate boundaries of water bodies using the active contours for segmentation. The next method is called change detection. It is most frequently used method for flood mapping. It compares dry season imagery with flood season imagery to see how the brightness varies due to flood, and then detects flooding. Now, we will briefly look at the various classification methods used in SAR image analysis. The supervised classification method is related to collecting water and non-water samples and then applying supervised classification algorithm. For example, identification of a random forest. Object-based classification or multi-temporal SAR data is related to segmentation of site rather than some rule-based classification. You can read more about picture-based classification and region growing to explore further. By now, you should have the basic understanding of how SAR images are used for mapping water surfaces and flooding. We will now move on to next module for hands-on activity to explore SAR images in Google Earth Engine. Thanks for watching.